Hello friends, today we are going to discuss one of the applications of partial differential equation. So far, we discussed various topics of engineering mathematics 2 and engineering mathematics 3 also. And as far as possible, I tried to cover maximum portion of Savitribai Phule Pune University for the subject engineering mathematics 3. In this video lecture, we are going to discuss applications of partial differential equation. In last year, you have gone through partial differentiation, and in engineering mathematics 3 and engineering mathematics 2, first order, first degree differential equation and higher order differential equation that we have studied. Now, only the applications of partial differential equation we are going to study. In applications of partial differential equation, as per the syllabus, the three topics or three major applications we are going to study. First one is the vibration of string, second one-dimensional heat flow, and third two-dimensional heat flow. In this video lecture, I am going to cover problems on vibration of string or wave equation. Problems on vibration of string or wave equation. Yes, prior to that, what is differential equation? Differential equation is an equation involving differential coefficients only. And what is partial differential equation? Partial differential equation is an equation involving partial differential coefficients or partial derivatives, you can say. In particular, here in applications of partial differential equation, as I said, three applications we have to study. As a formality, I would like to tell you what is applications or what is definition of partial differential equation. This partial differential equation is what? It is an equation, partial differential equation. Partial differential equation is an equation involving one or more derivatives, others say partial derivatives, of unknown variable. Partial derivatives of one or more partial derivatives of unknown. That unknown is depend on, two or more known variable. Okay, normally it is time t and one or more variable in a space. Okay, this is partial differential equation. As far as this topic is clear, partial differential equation is an equation containing one or more partial derivatives of unknown. You can say it is y or u, whatever. And that y or u displacement when we talk about the vibration of string, or heat when we talk about the one-dimensional or two-dimensional heat flow, the derivative of one or more derivative of u or y, and u and y depends on any two or more variables. You can take it as t, time t, or any displacement like that. Okay, as a formality I have given you definition. Now, in applications of partial differential equation, only the solution of differential equation will find. Okay, solution of differential equation will find. So in order to save time, this problem I have written on the sheet. The problem I am going to read. A tightly stretched string with fixed ends x equal to 0 and x equal to L. X equal to 0 and x equal to L. X equals 0 and x equals L. Here, the length of the string is L. Is it? And it is initially at rest position. If it is set vibrating, if you distort it, and if this is the string, and this string is kept along x-axis, and this is one end of the string, and this is another end of the string, and this string is tightly stretched, tightly stretched, and under some assumptions, we are going to solve this problem. Okay, this string should be uniform string or homogeneous, you can say. Homogeneous string means what? The mass per unit length of the string is constant. Okay, this string should be homogeneous or uniform. Then the string is so tightly stretched, where the gravitational force will be negligible. Where the gravitational force is what? Negligible. And this string, it is tightly stretched, and just like a violin string, everybody has seen violin string, and if this is a violin string, and if I distort it, allow it to distort, allow it to vibrate, then what is the assumption? That it should move in a vertical plane. It should move in a vertical plane. Means particle of the string, it should move vertically up and down in this way. And if it is being moved vertically up and down, then the slope at each point will be close to 0. Slope will be close to 0. See, graphically, this is a tightly stretched string, and if we allow it to vibrate, then the slope at each point is what? It is closer to 0. Slope at each point, at these 2 points, the slope at this point, is closer to 0. So here in this problem, what is given and what we have to find? Okay, what is given and what we have to find? See, this string is tightly stretched. It is fixed at these 2 ends, and at these 2 ends, y, at this end, y of xt is a function. Find the displacement, and y of xt, here I am writing, y of xt is the displacement. And that we have to find. Okay, this we have to find. But at this point, at one end of the string, y of 0t, okay, t is time, is 0. Displacement is 0 at this point, and the displacement is 0 at the next point also. At this point also, displacement is 0. And as I said, third condition also I am writing, at each point derivative of y, partial derivative of y with respect to t, when it allows it to vibrate at time t equal to 0 means which is equal to 0. And the fourth condition which is given to you, that is y of x0 equals 3lx minus x square. Okay, I have taken this x inside of the bracket, L into x, x into x is x square. Right? Under these four boundary conditions, we have to find out the solution of the differential equation. Now, the equation of vibration of string I am writing. Equation of vibration of string I am going to write. It is what? Del 2u by del t square equals c square is del 2u by del x square. Okay, I am not going to prove this because c square is the coefficient and which is taken which is c square, and in place of c square you may take k also. It's for the sake of solution of the differential equation, c square is taken. But instead of c square, you may be given any alphabet. Now, these four conditions are given, and u of xt we have to find. Instead of y, u, I am using y here. You can use u also. I am using y because we are dealing with the displacement. Now, the solution of this differential equation we can easily find, and this type of solution of this type of differential equation you have done in earlier years also. But in examination, if this problem is asked in the examination, then you have to start from the most general solution. Because how the most general solution is generated or came, that is immaterial. Okay, in examination. If you want the solution of this, it is given in the book, But in the examination, so no need to give the procedure how the solution has come. I am writing here most general solution. Most general solution. You have to start from this step. What is the most general solution? The y of xt. Y is a function of x and t. T is time and x is the displacement. What is the solution? C1 cos of mx plus C2 sin of mx. This multiplied by C3 cos of C into m into t plus C4 sin of C into m into t. Okay, this is our equation 1. Okay, this is the most general solution. I am letting this equation 1. Isn't it? Now, yes, one more thing I want to tell you, that x is 0, here at this point x is 0, where vertical displacement y is 0, this we have written, and the derivative of at each point is negligible, it is considered to be 0, and this is the condition, additional condition which is given to you. Yes, what does this mean? The string is slightly stretched now, and if this string is the violin string, and if you allow it to vibrate, if you push the string at any time or at time t equal to 0, then the displacement is given 3xl minus x, and y of xt you have to find. What is y of xt? It is a displacement at any point x. Displacement at any point x and at any time t. Displacement at any position of x at any time t. And what is this? This is the displacement when you allow it to vibrate, when you allow this string to vibrate at t equal to 0. Okay, this is the difference between these two. Try to understand. Okay. Now, the one by one conditions I will be using and we'll find out solution. Here, the first condition I am going to use. The first one I am going to use. What is the first condition? Y of 0t equals 0. Okay, means what I have to do? Put x equals 0 in equation 1. Put x equal to 0 in equation 1. If you put x equal to 0 in equation 1, then what we get? Y of, put x equal to 0. Put x equal to 0. C1 cos 0. C1 cos 0. Cos 0 is 1. C2 sin 0. Sin 0 is 0. C3 cos CMT plus C4 sin CMT. Okay, once again, I am putting x equal to 0. Here sin 0 is 0. Sin 0 is 0. And cos 0 is what? 1. If you put x equal to 0, cos 0 is 1 and sin 0 is 0. I am putting x equal to 0 only. I am keeping t as it is. Now, the y of 0t is given to you 0. It's a vertical displacement when x equal to 0 at this end is 0, 0 which is given to you. Okay, which is known to you. Then the product of these two equal to 0. Okay, product of C1 and this bracket equal to 0. Since x and t are independent, since horizontal displacement x and time t are independent, what did we do here? Tell me. I am putting x equal to 0. X and t are independent. Okay, this bracket is, you can say, t bracket, and this bracket is x bracket. X and t are, displacement x and t are independent of each other. X and t are independent of each other, and I will substitute here x equal to 0. Therefore, C1 product of these two is 0. Therefore, C1 must be 0. Therefore, C1 equal to 0. Because when you put x equal to 0, the time will not play a role. Okay. So therefore, C1 will be 0. So putting value of C1 in equation 1. If you put value of C1 in equation 1 here, then C1 equal to 1. C1 into cos 0, C1 into cos will be 0. Therefore, what will remain here? What will remain here? Y of xt, equation 1 implies. Put C1 equal to 0 in equation 1. C2 sin mx C3 cos CMT plus C4 sin CMT. Okay, so I will substitute C1 equal to 0, that's why. And our job is to find out value of C1, C2, C3, C4 and M also. Okay, M is the parameter which we are using, or constant which we are using. The value of M also we have to find. Means we have to find out 4 constants, C1, C2, C3, C4 and M. Now what I am going to do, just I am going to simplify it. And this step is not required. This step is not necessary at all. But here C2 into C3 I am multiplying, it will be C3 dash cos CMT, and C2 into C4 is C4 dash or C4 prime sin CMT. Okay, for the sake of simplicity I have done. This step is not at all required. Okay, what we have done here C2 into C3 is replaced by C3 dash, and C2 into C4 I have replaced by C4 dash. C1, C2, C3, C4 are general constant, and product of two general constant is again third general constant in that way. Okay. So this step is not at all required, but I have done so in order to have the simplified look to the solution. Now, y of x, this is our equation 2. This is our equation 2. Only one constant, value of one constant we found, and equation 2 we have found. Now I am going to apply second condition or third condition, whatever. So I am going to apply third condition. You are free to apply second condition also. So order is not important. Here in second and third. Second and third order is not important. Now I am going to use third condition. You may use second condition also initially. Okay. It's at this point. You can use second condition also. But here I am using third condition. This order is not important. Order of application of the condition is not important. Okay, this I am going to use. See, del y by del t at t equal to 0. Del y by del t at t equal to 0 is 0. This condition I am going to use. Now, what I have to do? I have to take derivative of y with respect to t. Differentiate to partially with respect to t, with respect to time t. Now what I am going to do? Del y by del t. Okay, this y, either you write y or y of xt is same. Okay, y or y of xt. Del y by del t is equal to, what is derivative of sine with respect to t? Sine of mx. So sine of mx will be constant because t is variable, x is constant here. I am taking partial derivative. C3 dash here multiplicative constant. Derivative of cos cmt is minus sine cmt. Okay, because t, this is t function, function of t you can say. This multiplied by coefficient of t is cm. Or you can say derivative of the argument cmt with respect to t is cm. Now c4 dash, derivative of sine is what? Cos of cmt is cmt. In bracket I have written, multiplied by cm. Okay, the partial derivative I have taken, and the derivative of y with respect to t I have taken. Now derivative of y with respect to t at t equal to 0. Sin mx as it is sin mx as it is. I am putting t equal to 0 means sin of 0 will be 0. See, sin of 0 is 0. So this will be 0. C4 dash, cos 0 is what? I am putting t equal to 0 means cos 0 is what? 1 into cm. And derivative of y with respect to t, time t, at t equal to 0 is 0. Okay, this is equal to 0. Sin of mx c4 dash into c into m. Okay, now x and t are independent of each other. I am substituting t equal to, I am dealing with the t now, remember. Initially we dealt with x. Now I am dealing with the time factor t. Since x and t are independent of each other, the sin of mx, sin of c4 dash, okay, since x and t are independent of each other, then it will not, this x term will not play an important role. Then c4 dash into c into m equal to 0. I am writing here c4 dash into c into m equal to 0. And m is never to be 0, because if m is 0 then everything will collapse. Then c is 0, then the differential equation will be of the another kind. Okay, it will not be the differential equation of vibration of string. C is not 0. C is not 0, M is not 0. Therefore, C4 dash equal to 0. So putting value of C4 dash here in equation 2. The equation 2 implies putting value of C4 dash in latest equation. That is C4 dash equal to 0. I have to substitute y of xt equal to sin mx into C3 dash cos cmt. Because C4 dash is going to become 0, because the value of C4 dash is 0. If you substitute C4 dash is 0, 0 multiplied by this will be 0. So we reach up to this equation. This is our equation 3. Now latest equation is our equation 3. The two conditions I applied. First condition, second, this condition and this condition. Now I am going to apply this condition. Okay. Which condition I am going to apply? Y of Lt equal to 0. This condition I am going to apply. So substitute, in order to apply this condition, put x equal to L. Okay. Put x equal to L and y of Lt equals 0. Okay, if you plug in this value, then y of Lt equals sine of m. I am putting x equal to L. C3 dash is as it is cos cmt. Now I am dealing with x here. Here I am dealing with x. Here I deal with t, time t. Here I deal with x with displacement x. Now y of Lt is 0, sin ml, C3 dash cos cmt. Okay, this is t, like this. I am dealing with x. Since x and t are independent of each other, so this will not play a role in solution here itself only. Therefore sin of ml equals 0, because product of these two is 0 and x and t are independent. Product of these two is the sin of ml must be 0, and sin of ml is 0, then this 0 sin ml equal to 0 can be expressed in terms of sin like this, sin n pi. Sin n pi. Therefore ml equal to n pi. This implies ml equals n pi. This implies m equal to n pi by l. M equal to n pi by l. Is it? In this way, value of m also we found. The substitute value of m in equation, latest equation, that is equation 3. Okay, substitute m is equal to n pi by l in equation, in latest equation, that is equation 3. Therefore, equation 3 implies y of xt is equal to put value of m is n pi by l sin n pi by l, this value of x sin mx into C3 dash cos cmt, cos c m is n pi by l t. Okay, and this argument of cos and sin I am writing in the bracket, not necessary, but I have written in the bracket. So far, 3 conditions I used, and with respect to these 3 conditions, 3 parameter or coefficient constants we have obtained. C1 equals 0, then C4 dash equals 0, then value of m. Now it remains to use this condition, y of x 0 equals 0. Now the last boundary condition, y of x0 equals 0 I have to use, that is 3 Lx minus x square. Lx minus x square, this way it is. Okay. Now, when you solve problem on vibration of string, in most of the problems, the first three conditions you will find common. These first three conditions are same, you will find common in most of the problems, not all. Therefore, the procedure of solution up to this step will be same. Procedure up to this step will be same. Means this much portion you have to repeat in maximum problems. This much portion of the solution part you have to repeat in almost all the problems. So in next problem, I will not be repeating this portion. Okay, you try to understand this. I will not be repeating this much portion. Directly this equation I will be writing when we solve the next problem. I will be writing this equation directly. Okay. So once again I tell you what is happening. This is partial differential equation of vibration of string or wave equation. This is the most general solution you have to remember, because proof of this is not required at all here in the examination. Three conditions you have to write: y0t, y del y by del t at t equals 0, these three, and fourth is given to you always. This condition may vary problem to problem. I am applying these three conditions. Initially, this I am going to apply y of 0 t equal to 0, and consequently the value of C1 is found to be 0. Substitute value of C1 here. This we have obtained. Then C2 into C3 is C3 dash, C2 into C4 is C4 dash. For convenience I have written. Now apply third condition. You may apply this condition also after this, but I am going to apply this one. Del y by del t at t equal to 0. Take derivative of y with respect to t. This is the derivative. Then substitute t equal to 0. Its value is 0, which is given in this way. The value of C4 dash we have obtained, and this plug this value in here. C4 dash is 0. If you put C4 dash is 0, then sin mx C3 dash cos cmt. Okay. Now the next condition is second condition I am going to apply. This condition, substitute L equal to 0 in the latest equation. Y of Lt is 0, x and t are independent, therefore sin ml equal to 0 and value of m equal to n pi by L we have found. Plug in this value here, this we have obtained. Means up to this step, the solution will be common. Solution, part of the solution will be common in almost all the problems. Okay, which are there in the syllabus of engineering mathematics. When we solve next problem, so this equation I will be writing directly. Okay, I will not be repeating this much portion. I will be writing this equation directly. But in the examination you have to do. But in order to save time, this equation I will be writing directly. Okay, now it is important to apply this condition. Y of x0 equal to 3 Lx minus x square. I have to apply this condition, means put t equal to 0, but time t equal to 0. Okay, time t equal to 0, this is given to you. And using this condition, I have to find out value of C3 dash. Try to understand. I have to find out value of, it remains to find out value of C3 dash now. Using these conditions, value of C3 dash we have to find. But here what happened? In this condition, algebraic functions are given. See, x functions are there. L is the length of the string. In examination, L may be replaced by 10 centimeter, okay, 10 units, 5 units, 1 unit, like that. Okay. The L is the length of the string, which is constant, and this is given, this condition is given in terms of algebraic function in terms of x, and using x function I have to find out the value of C3 dash, and C3 dash occurs here in the multiplication of cos and sine function. Cos and sine function. Okay. So how do you find out? So here I have to apply the Fourier series. In last year you have gone through Fourier series, because what is the Fourier series? Fourier series has a power to express algebraic function in terms of sine and cos function. Sine and cos functions are periodic, and periodicity is required in Fourier series. Algebraic function, this function can be expressed in sine and cos. Okay, using Fourier series that can be done. Therefore, I have to use the Fourier series here. Once again I tell you, this condition is given in terms of x algebraic function. Value of C3 dash I have to find, but C3 dash is associated with sine and cos function. Therefore, algebraic function I have to write in terms of sine and cos. How to write it? Using Fourier series. Now I am going to write here, this is equation 3 and this is equation 4. Okay, the rest of the part is important. Try to understand it. All solutions I am writing. All solutions y of xt equals summation n varies from 1 to infinity, because I have to apply the Fourier series. Sine n pi x by l into cos c n pi t by l. This is l, and this C3 dash is in this way I am writing b summation bn. Okay. Means all the solutions I have written, because I have to use the Fourier series. Means analytically, in short, you can write C3 dash is summation of Bn in this way. This is replaced by this in this way. But this is not correct way of representation. But C3 dash is replaced by summation Bn in this way. So this is our equation 5. This is our equation 5. See the difference. Now. The Fourier series I have to use. So I am using this condition. Put t equals 0. Put t equals 0 here. Then if you substitute t equal to 0, what will you get? If you substitute t equal to 0, because I have to use this condition. Remember, this condition I am going to use, and I have to substitute t equal to 0. Bn sine n pi x by l. See, sine, and I am writing sine n pi x by l, and cos of 0 is 1, because I am putting t equal to 0. Cos 0 is 1. Cos 0 is what? 1. Okay, this is half range Fourier series. This is what? It is half range Fourier series. Okay, for Fourier series for x lies between 0 and n. This is half range Fourier series, and you can easily find out value of Bn using Fourier series. How to find out the value of, if you recall the previous year Fourier series formula. So Bn equal to what? Bn I am writing. Bn is 2 by L, because x is in between 0 to L. 2 by L, 0 to L. This is L. Function of x into sine n pi x by L. This is Bn. You have to remember at this moment. Okay, you can say the Fourier series formula for Bn. Now here 0 to n, what is the function given to you? N pi x by L, as it is, we are integrating with respect to x. Okay. What is the function fx? See, this is the function fx. This function is function fx. In examination, this may be replaced by any function of x. Any function of x. Remember, any function of x. The fx is what? 3 lx minus x square. Okay. Now it remains to evaluate integral of this. 3 into 2 is 6 by L. Now use the integration by part. The generalized by part I am using. So you can integrate this function as per your method also. Generalized by part I am using. This is first function, this is second function, this is algebraic function, trigonometric function. Algebraic function is the first function, Lx minus x square is the first function. Integral of second function. Integral of sine is cos n pi x by L divided by n pi by L. First function, 3 I have taken outside. First function, integral of second, in the bracket I have written. Now, in generalized by part, second term, in second term, the minus sign by default you have to write. Okay, this is the Leibniz rule, you know. In last year we had done generalized by part rule. Now, derivative of this bracket is what? L minus 2x into integral of this. Here I am writing in this way because integral of this, integral of cos is sin n pi x by L. This divided by n pi by L, and n pi by L is already there, n square pi square by L square. Okay, then plus derivative of L minus 2x is what? Minus 2. Plus derivative of L minus 2x is minus 2, and integration of this bracket. Integration of sine is minus cos, minus minus will be plus. Integration of sine is minus cos, minus minus will be plus. Directly writing n pi x by L divided by n pi by L, and n square pi square by L is already there. After that, derivative of minus 2 will be 0. This is being terminated here. And once you integrate it, substitute, put lower limit and upper limit. Put x equal to L and x equal to 0 in the next step. So now I am putting x equal to 0, L, upper limit and lower limit. But if you look at this function very carefully, if you substitute x equal to L, the sin n pi by L, here I am writing sin n pi by L means sin n pi, and sin n pi is 0. Okay, if you substitute x equal to upper limit, the sin n pi is 0. Means this will be 0 for x equal to L. And if you substitute x equal to lower limit, the sin 0 is 0. Means for x equal to upper limit, for x equal to lower limit, this is going to become 0. This I have crossed out. Okay, in order to reduce length of the solution, I am doing so directly. But if you look at this function also, this term also, first term also, if you substitute x equal to L, the L square minus L square will be 0. Substitute x equal to L, L square minus L square is 0. If you substitute x equal to 0, then it will be 0. 0 into this will be 0. Means this term will disappear. Now, what I am going to do, 6 by L, only this term is remaining. Okay, minus 2 cos n pi x by L is divided by n cube pi cube by L cube. or 0 to L. Okay. Now -2 you can take outside. 2 into 6 is 12 with minus sign. L cube will jump in the numerator, therefore it will be L square n cube by pi cube as it is in the denominator. The cos of n pi x by L. Okay, this is variable term. It containing x, you know. This I have taken outside, -2 I have taken outside because it's free from x. Now, -12 L square by n cube pi cube. Put x equal to L. If you put x equal to L, then sin n pi L by L, it will be cos n pi, and cos n pi you can keep as it is, or you can write -1 to the power n, because the value of cos n pi for positive integer of n, it oscillates between -1 and 1. So put x equal to L, it will be what? -1 to the power n. If you put x equal to 0, cos 0 is 1. So at the most, this minus can be taken inside, not necessary, but you can take it inside. 1 minus -1 to the power n. So this is value of Bn. This is value of Bn. Now substitute value of Bn in equation, in this equation. See, in equation 5, this is our equation 5. I am substituting value of Bn in equation 5. Therefore, equation 5 implies, okay, the substitute value of Bn in equation 5. And equation 5 implies, what is equation 5? Y of xt is equal to summation n varies from 1 to infinity. Bn, see, Bn, in this bracket I will write Bn, sin n pi x by L into cos Cn pi t by L. And what is value of Bn? 12L square by n cube by cube -1 to the 1 minus -1 to the power n. So this is the displacement. We have to find out the displacement at any position x at any time t. At position x I am writing, because if you write x, you know, no need to write any. At any time t. Okay. So in this way we have solved this problem. At the most you can take, here in summation, n is the parameter and 12 you can take outside, then L square you can take outside. Other than n term you can take outside, which are multiplicative terms, and summation n varies from 1 to infinity. Then 12L square I have taken outside, 1 minus -1 to the power n as it is. Then L cube, pi cube I have taken outside, n cube will be there. Sin n pi x by L into cos Cn pi t by L. Okay, in this way we have found the displacement at position x at any time t. In this way we have solved this problem. Next problem, this equation. See, once again I repeat. So this equation 4 or equation 5, I will be writing directly, because conditions are set, first 3 conditions are set. Therefore, solution up to this step or this step, this or this, these two are same. Solutions will be same. Therefore, when we solve next problem, I will be writing this equation or this equation directly. Hope you understood it. I stop here. Thank you very much.